Welcome everyone to this math webinar to review the top tips for the most frequently tested geometry questions on the SAT and the ACT. Together today we're going to go through some geometry fundamentals, those core rules for lines, for graphing and solving lines, so stuff about slope and Y-intercept. We're going to go through circles, we're going to go through triangles, and then of course the most frequently tested two-dimensional and three-dimensional shapes. I'm thrilled to go through this program with you and to again do this great review of these most frequently tested geometry tips. So let's go ahead and get started with geometry fundamentals. For the geometry fundamentals questions we're going to do together, we're going to do two questions. Both are going to go over these essential rules that you absolutely must know for these geometry style questions that come up on the SAT and the ACT. So let's go ahead and start with this first question. It reads, in the figure below, C is on BD. So here we see point C on that line BD. Now remember, first thing I want to make sure you know is that a line equals 180 degrees. Now they tell us that BAC measures 42 degrees, so we see that that's labeled for us. And ABC measures 108 degrees, so we see that here as well, that 108 is labeled for us. Now, because they've given us some information about C being on line BD, and they've given us 2 out of 3 angles in a triangle, the second thing I want to make sure that you know is that a triangle, just like a line, equals 180 degrees. So we're going to use those 2 rules to solve this question. The question is asking us to find what is the measure of ACD? So we want to know what is this angle right here. So the first thing that we're going to do to solve this question is find what is this missing angle inside that triangle ABC. Because we know, of course, from rule number 2 that we just went over, that if we add the A plus B plus C that are all internal to that triangle together, it has to equal 180. Now they told us A, which they labeled was 42, B was 108, and then C, which I've labeled right here for us, I'll just make it darker, those added together is 180. 42 plus 108 is 150, so we know that 150 plus that missing angle C is 180. When we subtract 150 from both sides, we get that C is 30 degrees. So now what we have, I'm going to redraw, here's BD, and then here's point C kind of going like this. Notice I'm not drawing this to scale, but I'm going to label that we now know that that's 30 degrees, right? That's what we just figured out from over here. Now what we talked about first, of course, is that a line is 180 degrees, which means that from here to here, that purple that I'm labeling right there is 180 degrees. Remember, we're trying to solve for that missing angle. So we know, of course, that 30 right here plus x degrees has to equal 180, which is that line. Subtract 30 from both sides, we get that x is 150 degrees. That means that this part right here is 150, and same thing, this part right here is 150, so the correct answer to this question is E. All right, let's do another geometry fundamentals question. This one is a bit more challenging. So before we went over 2 really important rules, that a line is 180 and a triangle is 180. What we're going to do here, we're going to kind of bring back some of that, but also review how do we solve parallel lines cut by a transversal. So it says in the figure below, line M is perpendicular to line N. So we see that here where that's 90 degrees. Line P is parallel to line Q. Okay, so that means that this line here, P, is parallel to this line here, Q. Oh, I just drew that horribly. Let me redo that. There we go. So these are parallel to each other. Lines M, N, and P intersect at a single point. So M, N, and P all intersect at this one place right here that I just drew that dot. Some angle measures are given. What is the value of X? So what I'm going to do is what I want you to visualize here is if I have these 2 lines, P and Q, and they are cut by this transversal N. Okay, so I'm going to redraw that to the right. Here's P, here's Q. I'll go ahead and label them. Here's P, here's Q. They're parallel to each other. And I'm going to cut them just with n, that transversal n, and then I'm going to label, actually let me change my color, I'm going to label that that angle was 32. Now what we know from parallel lines cut by transversals is that if that angle is 32, remember vertical angles are the same, so this one's 32. Then we know opposite interior angles are the same, so we know this one's 32, and then its vertical angle is right here, this one's 32. Now, what we just talked about in the prior question, of course, is that a line equals 180 degrees. So I know that right here, from here to here is 180. So if I redraw that, here's a line, here's where it's being cut, this part's 32. So if this part is x, I know that those two added together, it has to be 180. So I know that 32 plus x is 180, subtract 32 from both sides, I get that x is 148 degrees. So again, what happened here is if this part was 32, this one was 32, this one was 32, and this one was 32. And then again, what I did was just look and think, okay, how do I then find x? Well, I know that this part right here, and again, you can extend that line if it helps you to visualize, this whole part was 180. So the x, which is what I was solving for, which was our correct answer of 148, had to be that missing part after I took 32 degrees out of the line, which was, of course, 180. For our graphing and solving lines portion, we're going to do 4 questions together. 2 of them are from the easier section of a real test, and then 2 of them are from the medium section of a real test. So as you can see, graphing and solving lines, this concept tends to appear earlier on in the test. Of course, remember in the math section, both on the SAT and the ACT, the questions get harder as you increase the number. So graphing and solving lines, very, very important, tested frequently, and again, tends to show up a little bit earlier on, more in the early portions or the middle portions of the sections. So the first thing I want to do for this question is just do a quick review that the equation of a line, right, y equals mx plus b, and the first thing I want to make sure that you know is which one is slope. Now remember that this m right here is the slope of that line. It's the rise over run, right? It's how much it goes up and over, or how much it goes down and over each time you change by a unit on the x-axis. So if we have a question and it's written like this and all we want to know is the slope, well, our goal is to get the equation to be in terms of just y equals, because if we can get y by itself and then the rest is in this form mx plus b, we're going to immediately know our answer to the question, which is asking us for slope, because it's going to be whatever number is right here in front of the x. So again, our goal is to take the 7x equals 9y plus 18 and move everything around so that we get y by itself. So the first thing that I'm going to do is I'm going to subtract 18 from both sides. Again, my goal here is to get y alone. I end up with 7x minus 18 equals 9y. Now to get y by itself, because it's being multiplied by 9, I'm going to divide everything by 9 so that it will cancel on that other side. So I end up with 7 over 9x minus 18 over 9. Remember, this over 9 you have to apply to every part, the 7x part and the minus 18 part. So I've rewritten it where I've put both parts over 9. That's equal to y. Now technically at this point, if we needed the full equation of the line, I would simplify one step further and do 7/9 x minus 2 equals y. But we don't actually have to do that here because it's only asking us to find the slope. And remember, the slope is right here. It's what's in front of the x. So the correct answer is 7 over 9, which is b. And if you're a little bit confused right now, remember that if you write something like 7/9 x minus 18 over 9 equals y, you can flip it, and that's the same thing as y equals 7 over 9x minus 18 over 9, right? So the fact that we got y by itself, it didn't matter if it was on the right side of the equals or the left side of the equals, we still got the same answer. Okay, so that first question, again, just gave us this very good introductory review. when you have the equation of a line in slope-intercept form, that m, right, is in front of the x, that is the slope. All right, so for this next one, it wants to know one of the following equations. So one of these equations right here represents the line that they've given us that's graphed below. So we have to now look at this line and figure out which equation, A, B, C, D, or E, is the equation for the line. So the first thing that I want you to recognize is the y-intercept. Now we haven't talked about that yet, but let's go back to our equation in slope-intercept form. We already talked about how this m right here is the slope, but we have not yet reviewed what this b is right here, which is the y-intercept. Now remember, the y-intercept is going to be the value of y when x is 0. So when x is 0, where are we? It's basically what is the point where we intercept the y-axis. So what we notice here is that the y-intercept is going to be 4, because when x equals 0, y equals 4. It's the place where the line crosses the y-axis. So the first thing I'm going to know for this question is that the plus b, that b equals 4, because that is our y-intercept. So looking at our answer choices, we can basically immediately cross out, because see how these say plus 2, minus 2, plus 2? Remember, we were going to want it to say plus 4. So the first thing we can do is cross out A, D, and E. Now the question is, what is the slope that we want? So let's solve for that purple part now and find the slope. Now if you look at this line and know immediately that the slope is negative, then good for you. You would know right away that the correct answer is B. I do want to show you how to solve for the equation, or how to solve for a slope, using that equation. But if you do look at this and know right away, okay, a negative slope goes this direction, positive slope goes this direction, slope of 0 goes this direction, then that's amazing. And that will definitely help you get the answer quicker. But again, I do want to show what is our equation for slope. It's the difference in our y's over the difference in our x's. So we know that we already have the point 0, 4, so that's going to be one of our points. The other point we have here is 2, 0. So if this one's x1 and this one's y1 and this one's x2 and this one's y2, put little commas in between them, then our slope is y2, which is 0, minus y1, which is 4, over x2, which is 2, minus x1, which is 0. 0 minus 4 on top is negative 4. 2 minus 0 on the bottom is 2. Negative 4 over 2, guess what? Our slope is negative 2. Now I know that we'd already kind of chatted about that because of our 2 answer choices left. We wanted the negative 1. But again, if you solved, and it is really good to just review that equation to make sure that you know what is the equation for slope and how do I find slope. Lindsay plotted the data from her science project as a scatter plot in the standard XY coordinate plane. So a scatter plot is basically what you see below, where it has all of these little dots here, here, here. So those are all data points, right, of whatever she's plotting. She found the line containing 2 of the points to be this line right here, y equals 0.28x plus 6. So she's basically trying to say, hey, this line is supposed to represent what my scatter plot looks like, what my data look like. The scatter plot and the line are shown below. Lindsay decided, by the way correctly, that this line was not a good fit for her data. So a line that would be a good fit for her data would look more like this, right? So it would kind of go through her scatter plot and all of those data points. So the line that got sketched as this kind of line of best fit, the y equals 0.28x plus 6, that blue line, is not a good fit for the scatter plot data. The one I drew in green, that one is a better fit for her data. So the question is basically saying, if we want to change from the blue line to the green line, right, we want to go from the one that wasn't a good fit to the one that is a good fit, what does Lindsay need to do? So the first thing I want you to recognize is with the y-intercept. So I'm going to talk about the y-intercept with purple. So here was the original y-intercept up here at 6. But notice with our green line that our new y-intercept goes down. It gets lower, right? It becomes like a 1. So the first thing I'm going to see here that she's going to do is she's going to decrease the y-intercept. Now look at the slope. Remember, the original slope is kind of this shape. The new slope gets steeper. So remember, if a slope gets steeper, that means that you are increasing the slope. So for her to transform this line for her data, what does Lindsay need to do? She needs to increase the slope and she needs to decrease the y-intercept. So I think that correct answer for us is going to be B. Let me just double check it again. Increase the slope. Yes, that's what we want to do. Decrease the y-intercept. Yes, that's what we want to do. So what I hope you recognize in this question is that it was a bit more challenging application of understanding what is a slope and what is a y-intercept. So those earlier questions were kind of more easy style. This one now is medium. So for our last question on graphing and solving lines, again, we're going to kind of pull everything together that we've already reviewed. In the standard xy coordinate plane below, triangle AOB is formed by this line AB, which we can see is drawn for us, the x-axis and the y-axis. Okay, so we basically have this triangle right here. There's the y-axis, there's the x-axis, and here's the part that's formed from the line AB. Which of the following is an equation of AB? All right, well, remember, when we have an equation, we have y equals mx plus b. Our job is to figure out what is the slope, what is the y-intercept. Let's start with the y-intercept because that one's going to be easier. Remember, the y-intercept, I'm going to label these again. The y-intercept is the value of y when x is 0. Notice that we have the point 0, 6. That means that y is 6 when x is 0, which means that b is 6. Our y-intercept right here, y-intercept is 6. So now we're going to figure out, well, what is our slope? Remember, our slope, we're going to calculate from y2 minus y1 over x2 minus x1. What are our 2 points? Our 2 points are 0, 6 and 6, 0. So we have x1 and y1, and then we have the second x value and the second y value. So our slope is going to be y2, which is 0, minus y1, which is 6, over x2, which is 6, minus x1, which is 0. Negative 6 on top, 6 on the bottom. Our slope is negative 1. So what I'm going to do is I'm going to say my slope is negative 1. My y-intercept is 6. And so when I take that information and I plug it in, I'm going to have y equals negative 1, which is our slope, times x, plus b, and remember b, the y-intercept, was 6. So the correct answer is y equals negative 1x plus 6. Remember that this negative 1, that 1 can kind of be invisible, and you can cross it out, and it's just the same thing as y equals negative x plus 6. So it looks like A is going to be the correct answer to this question. So again, this one was a medium level difficulty, but we just applied the same exact knowledge from our prior questions that were easier. We knew the slope-intercept equation of a line. We knew how to find the B, the y-intercept. We knew how to find the M. And then it was just plugging in the numbers, working carefully with negative signs, and then plugging in to the equation. For the circles questions that we're going to review together, we're going to do 4 questions, and these tend to be more from the medium to the hard area of the exams. So again, you've seen so far that some of the other concepts tend to be concentrated more earlier on in the test, where maybe things are a little bit easier to medium level difficulty. Circle questions tend to start to show up kind of in the middle to the end, where things are a bit more challenging. Now, of course, my goal is to be able to break these down for you that they feel much easier and much more straightforward, even though, again, these questions might occur in the more medium to hard sections. So here we go for our circles questions. It has points A, B, D, and E lie on the circle shown below. Okay, so basically all that they're saying is that what we see here in the picture with A, B, D, and E, they are in fact on the circle. Secants AC and CE intersect at C. So they're just saying basically that this secant line AC and this one here, CE, are intersecting at that point C. The chords AB and DE are congruent. Now this part's really important. If this length, AB, is congruent, which means equal to this length, DE, that means that this angle from A to B and the angle from D to E are the same. So right here, AB, I'm going to label X degrees, and right here, DE, I'm going to label X degrees. Then, what do they tell us next? And notice that I labeled them both X, not different variables, because I want them to be the same. They're both the same angle. Then they tell us that right here, from A to E, ooh, I did not draw that well, let me redo that. From A to E is 108 degrees, and from B to D is 62 degrees. Now, the first thing I want to make sure that you remember to solve this question is that in a circle, when you add everything up, all those angles, it should be 360 degrees. So when I have my 108 from AE, and I add that to 62 from BD, and then I add my X that goes from AB plus my X that goes from D to E, what should that equal? It should equal 360. So now 108 plus 62 is 170, plus X is 2X. Remember that X times X is X squared, but X plus X is like 1X plus 1X. What is 1 plus 1? It's 2X. So we know that 170 plus 2X equals 360. Subtract 170 from both sides, and I get that 2X equals 360 minus 170, which is 190. To get X by itself, it's being multiplied by 2. I'm going to do the opposite and divide by 2 on both sides. And I get that X equals 95 degrees. So now I know that from A to B is 95 degrees, and from D to E is 95 degrees. So what is our question? Our question is asking us, what is the measure of minor arc DE? So it's asking us what are those degrees right there, which we just figured out, 95 degrees, so our answer is E. Two concentric circles. Okay, what does that mean? Con means with, right, for those of you who study or speak Spanish. So concentric circles with center. Concentric is like with center. It basically means that they have the same center. So I'm going to draw a center, and then I'm going to draw two concentric circles, two circles that have the same center. And please excuse my circle drawing skills. Hopefully they won't be too bad. Here comes the second one. Okay, not horrible. Not the best, but not terrible. Okay, so here is my center that they both share. One has a radius of 4 centimeters. So the distance from here to here is going to be 4 centimeters. The other one has a radius of 5 centimeters, which means that from that same center to there is 5 centimeters, which of course means this difference from there to there is 1, right? If it's 4 centimeters from the center to the outside of the smaller one, and it's 5 centimeters from the smaller to the outside of the larger one, then of course that difference is just 1 centimeter. How many centimeters longer is the circumference of the larger circle than the circumference of the smaller circle? Okay, so here we go. We're going to have to find the circumference twice, once for the smaller one, once for the bigger one. What is our equation of circumference? Remember that circumference of a circle is 2 times pi times r. And remember, r is the radius. So we have the radii, right? They've told that to us. So in our first circle, the radius was 4 centimeters. So we're going to take that 4 and plug it into the radius. That means that the circumference of our first circle is 2 times pi times 4, which is 2 times 4, which is 8 pi. So the circumference of our first circle of our smaller circle is 8 pi. Now let's look at our larger circle. So remember, we've already taken care what was the circumference of the circle with a radius of 4. Now let's do the one with a radius of 5. So we're going to do the same thing. We're going to take that value of r, plug it in. That means that the circumference is 2 times pi times 5. 2 times 5 is 10. So that means that the circumference of our second circle is 10 pi. Now the question asks, how many centimeters longer is the circumference of the larger one than the circumference of the smaller one? So it's basically asking us 10 pi is how much bigger than 8 pi? Well, we're going to be able to solve that by doing 10 pi minus 8 pi, right? What is the difference between those two circumferences? And then that tells us how much longer is the circumference of the larger circle compared to the circumference of the smaller circle. 10 pi minus 8 pi is just 10 minus 8, which is 2 times pi. So 2 pi is going to be our answer, which is option C. All right, so now we're into the harder questions for circles. It looks like we're looking at a semicircular top. Remember that a semicircle is half of a circle. So this guy, Ron, has a patio, and what we're looking at below is kind of an image of what his patio top looks like. Which of the following values is closest to the area in square feet? Okay, really quickly, feet, they're giving us the units in feet, so we don't have to worry about the units. So it's basically saying what is the area of half of a circle? That's given to us below. Remember, semicircle is half of a circle. When we know that the diameter is 12. So remember, in the prior question, they were giving us information about the radius, information from just the center to the outside. But now they're telling us this full distance, which is the diameter. And remember that the diameter is the same thing as 2 of the radius. So the first thing I want to do is go, okay, if the diameter is 12 feet, the radius has to be half of that, which is 6 feet. The reason I want to make sure that I'm careful here is that a lot of students make the mistake of creating the equation of a circle. They know it's pi r squared, but then they put in a 12 for the radius because they forget that extra step of going from the diameter to the radius. So the first thing you're going to want to do is take that d of 12 feet and calculate what's the radius of 6 feet. Then we know that the area of a circle is pi r squared, which means that the area of half of a circle is going to be pi r squared divided by 2. So now let's plug in what we know. Well, we know that the radius was only 6 feet, right? Right here, this part was 6, the radius was 6, so I'm going to plug that in for r. So I'm going to have pi times the radius of 6 squared divided by 2. Let's do that 6 squared on top first. 6 squared is 36. So I have 36 pi on top divided by 2. 36 divided by 2, 18 times pi. Now it asks us which of the following values is closest. So if we look at the answer choices, notice that 18 pi is not an answer choice. Now 18 pi would be our precise answer, but if we're just trying to get as close as possible, remember pi is 3.14 approximately, so you could do 18 times 3.14, right, or 18 times pi, and then just see which one you're closest to. So 18 times pi is 56.54, kind of etc., because we have more decimals coming later. Which answer choice is that closest to? Well, that's closest to C, which is 54, which would have been calculated as just the 18 times 3 instead of 18 times the actual value of pi, which is the 3.14159, etc. So again, if this question had asked us for the exact answer, our exact answer would need to be 18 pi. Because it just said which one is closest, that's why we're able to round and get to the closest value of 54. Okay, so for this last question on circles, notice so far, right, very deliberately, we've covered circumference equation, we've covered area equation. Now we're going to cover what is just the equation of a circle. So what I want to make sure that you know is that the equation of a circle is x minus h squared plus y minus k squared equals r squared. And that is true when h comma k is the center of the circle and when r is the radius of a circle. So what have they told us? They've told us that it has a center of -1, 4, which means that we want our center to be -1, 4, and it has a radius of 6. So we're going to want our r to be 6. So what I'm going to do, I'm going to use a lot of color coding here. So here's my h, here's my h. I'm going to take -1 and plug it in for h. Then notice my k, my k, my k. I'm going to plug a 4 in for k. And then the last thing I'm going to do is notice my r. Here's my r, and what was r? R was 6. So I'm going to plug 6 in for r. So when I do that, I'm going to come over here, plugging in those numbers. I'm going to have x minus, now notice that h is -1, so be very careful with your negative signs, plus y minus, what was k? K was 4, so square that, equals r, which was 6 squared. The hardest part of going from the hk to the equation of a circle is watching your negative signs. If h is -1, then when you end up plugging in -1 and then subtracting a negative, that of course turns into a positive. So the x minus -1 has to turn into x plus 1 quantity squared plus y minus 4 quantity squared equals 36. So when we go to our answer choices, it looks like the correct answer is going to be D. But again, if you look at answer choice E, the signs are different, right? Instead of x plus 1, it's x minus 1. Instead of y minus 4, it's y plus 4. That's deliberate, right? That's there to trap students who don't know what to do with minusing inside and then what to do with minus of a negative. So again, when it comes to circles, the questions can be medium to hard level difficulty, but if you just know the equations and know where to put the right things in, it can become very simple to solve these questions, which of course is our goal at Winward Academy, is to make things as clear and as straightforward as possible, so when you see these questions, you know exactly what to do. For our triangles questions, we're actually going to do 8 together. And the reason we're doing more questions in triangles than we are in the other sections is that I want to make sure that we cover a lot of the different topics that come up with triangles, right? So with triangles, you can see questions that are earlier in the easy questions. You can see triangle questions in the middle when they're medium, and you can see triangle questions at the end when they're hard. You can also see a lot of different questions. You can see ones that require Pythagorean Theorem, SOHCAHTOA, special right triangles with 45, 45, 90, and also area of a triangle. So there are a lot of those kind of different nuanced topics that I want to make sure we do a little bit of review for each one. Plus, I want to make sure to expose you to what these questions look like when they're easy, medium, and hard. So again, that's why we're doing 8 triangle questions together. And let's go ahead and jump in with an easy question in which we use Pythagorean Theorem to solve. So it says, what is the length in inches of the hypotenuse of a right triangle? So the first thing I'm going to do is just pause for a second with what I'm reading, and I'm going to draw a right triangle. Now notice that they've told us that it is a right triangle, which means we know that it has a 90-degree angle, and we want to solve for the hypotenuse. And the hypotenuse is going to be the longest side because it is opposite the biggest angle of 90 degrees. Now they tell us that one leg is 7 inches and the other one is 3 inches. So the good thing here is that our units, we have inches, inches, and inches. So we don't have to worry about changing our hypotenuse answer to a different unit. They're all the same inches. So if one is 3 inches and one is 7 inches, our question is, how long is the hypotenuse? So what I want to make sure you remember is that when you have a right triangle, again, only when you have a right triangle where you know that there is that 90-degree angle, you know that the ratio among the 2 legs plus the hypotenuse, or the ratio among the 3 sides, is defined by Pythagorean Theorem, which is that a squared plus b squared equals c squared. That's where a is a leg, so I'm going to make a equal 3 inches. B is a leg, so I'm going to make b equal 7 inches. And c is the hypotenuse. So I'm just going to plug in here. If a is 3, I know that 3 squared plus, if b is 7, 7 squared equals our hypotenuse c squared. So now all I have to do is solve kind of a straightforward algebra type problem or arithmetic problem, right, where I'm just solving these numbers. So 3 squared is 9 plus 7 squared is 49 equals c squared. 9 plus 49 is 58, so I get that 58 equals c squared. I'm just going to flip how this is written so that my c answer can be on the left. Now, because I'm squaring c, I need to cancel that square so I can get c by itself. How do I cancel a square? I take the square root. So the reason I do that, of course, is that the square root of c squared will just cancel, and then I'm left with c equals. Now this part's really important because I started with c squared and I took the square root. My answer has to be that c equals plus or minus root 58. Now, because we are solving for the length of a side, right, a distance can never be negative, so I can ignore the negative answer. However, you have to be in the habit of any time you see like x squared is a number or c squared is a number, when you take that square root, your answer has to be plus or minus. Then you make the judgment call of whether both are possible or whether you have to get rid of a negative one because a negative answer isn't possible. But again, yes, it's true that this one has to be the positive answer, but I want you to be in the habit of always writing plus or minus when you start with a squared variable and take the square root to solve. Okay, that was a little bit tangential. Our answer is that c is at the positive square root of 58, so the answer is B. And again, you can only use Pythagorean theorem right here when you have a right triangle. The biggest mistake students make is a question does not say that there's a 90-degree angle. It does not say that it's a right triangle, and students try to solve using Pythagorean theorem. You cannot do that. Pythagorean theorem is only for right triangles. Let's do another one with Pythagorean theorem. Notice in this first question, they gave us a leg, and then our job was to find the hypotenuse. In this question, they're going to give us a leg and the hypotenuse, and our job is to find the other leg. So what do we have? It says the length of the hypotenuse of a certain right triangle is 50 inches. Okay, so here comes my right triangle again. Doesn't have to be perfect. There's my right angle, right, my 90-degree angle. They tell us the hypotenuse is 50 inches. The length of one of its legs is 30 inches. So I'm going to put 30 inches for one of the legs. What is the length in inches? So notice that the unit stayed the same of the other leg. So if this one's B, I don't know how long is this other leg B. Now, because it's a right triangle, we can use our same a squared plus b squared equals c squared. Our A is 30 and our C hypotenuse is 50, and then of course we don't know what B is. That's what we're solving for, is that other leg. So we have A is 30 squared plus B we don't know squared equals C, which is 50 squared. That's 900 plus B squared equals 2500. Subtract 900 from both sides and I get that B squared equals 1600. Just as I did before, because I'm squaring B, I'm going to do the opposite and take the square root of both sides so that I can get B by itself. The square root of B squared is B equals plus or minus the square root of 1600. Now again, as we chatted about before, because I'm solving for a distance, I can ignore the negative answer, but I'm going to have very good habits of any time I start with something squared and take the square root, I'm going to do plus or minus. That means that B equals the positive square root of 1600, which is 40. So the correct answer to this question is C. Really quickly before we move on, I want to do a quick shout out to Pythagorean Triplets. So remember that after you learn Pythagorean theorem, there are certain lengths of two legs and a hypotenuse that always go together in the same ratio. So hopefully you remember learning 3, 4, 5. Right? If you have a leg of 3 and a leg of 4, the hypotenuse is 5. Multiply all of those by 2, you have that 6, 8, 10 will also always occur in a right triangle. If a leg is 6 and a leg is 8, the hypotenuse is 10. If a leg is 6 and the hypotenuse is 10, the other leg is 8. Right? So these are always going to go in the ratio of leg, leg, hypotenuse. So if you look carefully, what happens if we start with that original 3, 4, 5 and multiply everything by 10? We get 30, 40, 50, which guess what is exactly what we just had in this question. So we had a leg of 30 and a leg of 40. Here was 30, here was 40, and then we had a hypotenuse of 50. So in this question, once you saw a leg of 30 and a hypotenuse of 50, if you remembered your Pythagorean triplets, you would immediately know that that missing leg was 40. If you don't know your Pythagorean triplets, that's okay, because of course you can just solve using Pythagorean theorem. It just takes a little bit longer. Okay, moving on from easy questions to now medium level difficulty questions. The triangle below has side lengths given in meters. Okay, so this 10 is going to be meters and x is going to be meters. Which of the following expressions is equal to x? So notice in this question, we're not going to be using Pythagorean theorem. Yes, it has a 90-degree angle, but to use Pythagorean theorem, out of the 3 sides of the triangle, out of the 2 legs and the hypotenuse, you have to have 2 of them. That's not what's happening here, right? In this question, we've been given an angle, and from that angle, we want to solve for the length of a side opposite, and we know how long is the side between that angle and the 90 degrees. So this time when we're solving a right triangle, we are going to use SOH, CA, TOA. So the first part here is to know which one do I want to use. Do I want to use sine, which goes with SOH, cosine, which goes with the CA, or tangent, which goes with the TOA? And the answer is that from our angle, we want opposite, and we have adjacent. Because remember, opposite the 90 degree is always the hypotenuse. And both the SOH, right, has a hypotenuse, the CA has hypotenuse, so SOH and CA are out. From our 35 degree angle, we want what's opposite, and we have what's adjacent. That means that we want the O and we have the A. So let's break this down. TOA means that the tangent of 35 degrees equals opposite of that angle, which is x, the length x, over adjacent. Remember, adjacent is going to be the length of the side that goes from the angle to the 90 degrees. So the length of that adjacent side was 10 meters. Now, how do we solve for x? Well, x is being divided by 10, so we'll do the opposite and multiply by 10 on both sides. So I get that 10 times the tangent of 35 degrees equals x, because of course these 10s cancel. So the correct answer is E. The length of this missing side x, which was opposite the 35 degrees, was 10 times the tangent of 35. Let's do another SOH-CA-TOA problem, still medium level difficulty. In the figure shown below, a ladder 15 feet long, okay, so here's our ladder that's 15 feet long that's leaning up against that building. It says that it forms an angle of 56 degrees with the level ground as it leans against the vertical side of a building. So the fact that this building is vertical with the ground means that if here's the ground, it's going to form a 90-degree angle. So that's why they tell us that the building is vertical, because then we know, okay, if it's perfectly vertical, then we know that that's a 90-degree angle. The distance along the building in feet between the ground and the top of the ladder. So here's the ground, here's the top of the ladder. That means I want to solve for that length right there that I just labeled in purple. That's going to be our x. How long is that distance, right? That is what we're solving for in feet. And notice that the 15 that they gave to us was also in feet, so we don't need to worry about the units because they match. So I have a side, I have an angle, and then I want to solve for a side that is opposite the angle that I've been given. So let's go to SOH-CA-TOA and let's figure out which one do we want. So again, from our angle of 56, we want opposite, and we have hypotenuse. So that means that we want the O, the opposite, and we have the H, the hypotenuse. That means that we're going to use SOH to solve, which means we're going to use sine. So remember, the so means that the sine of 56 degrees equals whatever's opposite that 56 degrees over the hypotenuse of the triangle. Now, what is opposite the 56 degree angle is x, which we're trying to solve for, over the hypotenuse, which is 15. So if I know that the sine of 56 equals x over 15, because I am dividing by 15 to get x by itself, I'm going to do the opposite and multiply by 15 on both sides so that they cancel. And I'm left with 15 times the sine of 56 equals x. So it looks like the correct answer is C. Another medium level difficulty question. This time we're going to review area of a triangle. In the standard xy coordinate plane below, triangle AOB is formed by this line, AB. The x-axis, okay, so basically it's formed here with the x-axis and with the y-axis. What is the area of triangle AOB? Okay, well, to find the area of a triangle, the equation is 1/2 times the base times the vertical height of the triangle. So let's start with the base. The base is going to be this length here, where we're going from the point 0, 0 to the point 6, 0. That means that from the origin 0, 0, we move to the right 6 to get to the point 6, 0. That means that the length of our base is 6. So I'm going to plug in a 6 for B. Now let's review the height. So here's our height. We go from 0, 0 to the point 0, 6, which means that our y value changes from 0 to 6, which means that we go up 6. So that length for our height is also 6. So now to find the area of this triangle, all we have to do is 1/2 times the base of 6 times the height of 6. That turns into 1/2 times 6 over 1 times 6 over 1. Remember, 6 is just the same thing as 6 over 1. So now when we're kind of thinking about multiplying fractions, our top is 1 times 6, which is 36, over the bottom, which is 2 times 1, which is 2. And 36 divided by 2 is 18. So 18 square units will be the area of this triangle. So the answer is D. What is the length of AB in coordinate units? So notice that this question is now kind of building off the prior one. And remember that what we did in that prior question is we figured out that the length, let me go ahead and redraw this really quickly. Here was A, here was B, and here was O. We figured out that this length here was 6 and that this length here was 6. So now the question is, what is the length of AB? What is this length here from A to B? Now, what you want to remember for this question is first, yes, you can use Pythagorean Theorem. You could do 6 squared plus 6 squared equals C squared and then solve for C, just like we did with those first couple questions in which we reviewed Pythagorean Theorem. And of course, by the way, this is a right triangle, because in an XY coordinate plane, you know that the X and Y axis form a 90-degree angle. They're perpendicular to each other. So the first way to do it is, yes, you can use Pythagorean Theorem, but I want to show you and hopefully remind you that if you have a special right triangle where the legs are the same, well, if the leg lengths are the same, that means that the angles opposite them are the same. And if we know that these three angles add up to 180, but one of them is 90, that means that these two angles that are left have to be the same. And if they have to be the same and they add up to 90, because of course the whole triangle adds up to 180, well then guess what? Each of those angles is 45 degrees. So I know that this angle is 45, and I know that this angle is 45 as well. Then, if you remember your rules about special right triangles, in a 45, 45, 90 triangle, the ratio of the sides is that what's opposite the 45s are the same, right? Of course, by definition, if the angles are the same, then the lengths opposite them are the same. And then the rule is that if you have that x value for what's opposite the 45, then what's opposite the 90 is x root 2. So if you look at this question and immediately recognize, oh, this is a 45, 45, 90 triangle. The ratio of the sides is x to x root 2. I know that x is 6, so I know that my ratio of my sides is 6 to 6 root 2. Well, guess what? If you can remember that sequence, you can recognize 45, 45, 90. You can remember the ratios, x to x root 2. Then you plug in that x is 6, and you immediately know your sides go 6, 6, and 6 root 2. Boom, you know that the answer is 6 root 2, that this length from A to B is 6 root 2. Now, you would have gotten the exact same answer using Pythagorean Theorem. I just wanted to use this question as a great way to review 45, 45, 90 triangles, those special right triangles where you can memorize the ratio of the sides. All right, we're getting down to our final two questions on triangles, and these are both hard questions. So they were in kind of the later set of questions. In triangle ABC below, the measure of ABD is 70. Okay, so there's that one right there. The measure of ACB is 32. Okay, so that one's right there. D is on BC. Okay, so that means that this is a line from C to B and that point D is on it. And AD is a bisector of BAC. So from B to A to C. If this line AD is a bisector, that means that it is cutting it in half, which means that this angle, which I will label X, is the same as this angle, which I will also label X. Because again, if this line is cutting this angle right here in half, that's what a bisector is, then each of those angles is both X. So the question is asking us, what is the measure of ADB? So the correct answer to this question is going to be when we can figure out what is this angle here. Okay, so what I want you to do first is kind of take a step back, because it's easy to get sucked into trying to solve for this missing angle, but then you go, well, wait a minute, I have a 70 and I have an X, but then I also don't have what I'm looking for. I feel stuck, right? So what I want you to do is take a step back and look at the full triangle first. I want you to start by looking at triangle ABC, the big one. So going from this point to this point to this point. If you look at that big triangle ABC, if you remember that all those angles are going to add up to 180, then you know that A plus B plus C has to equal 180 degrees. Well, angle A right here is the same thing as an X plus another X. So that's 2X is going to be that angle. B was 70 and C was 32. And we know that they add to 180. That means that 2X plus 102, that's 70 plus 32, is 180. 180 minus the 102 leaves us with 2X equals 78. Divide both sides by 2, and I get that X equals 39. So now, when I come back over to my triangle, what I'm going to do is just kind of erase what I've done here so far to clean it up. Remember, this one was X and this one was X, and I just figured out that this part is 39 degrees. So now I have this triangle, triangle ABD, that looks like this. I'm just going to redraw it for us. ABD, where we know that this part here was 39, this part was 70, and then, aha, this angle is what I'm trying to solve for. That's the one that's missing, which is that angle D. So for triangle ABD, we know the same thing, right? That A plus B plus D equals 180. Let me draw a little line here to separate our prior work. A, we just figured out, was 39. B is 70. D is what we're trying to solve. They add to 180. 39 plus 70 is 109 plus D equals 180. 180 minus 109, we know that D equals 71 degrees. So our correct answer is C. So to solve this problem, you had to know something very basic, that in a triangle, all the angles add to 180. Now, knowing that basic information is great, but we had to apply it to this harder question because we had to do it twice, and we had to recognize that before we could really focus on solving for this part, we had to first solve for this full part for A by looking at the bigger triangle. After we had solved that bigger part, then we were able to zone in on the smaller triangle within it. Okay, last question on triangles. We're going to bring it back to SOHCAHTOA, but it's going to be a little bit more challenging. So let's see what we have here. Skyline Tours is offering hot air balloon tours. The table below gives information about the balloon, the equipment, and the tours offered. Jared is looking up at the hot air balloon. So here's Jared right here looking up. Here's the balloon. The balloon is currently at the maximum altitude during Tour B. Okay, so I'm going to pause for a second. The altitude, right, is going to be how high up the balloon is, so kind of the distance between the ground and the height of the balloon. If it's at the maximum altitude during Tour B, I'm going to look at Tour B. I'm going to find my maximum altitude right here is 600. So I now know that this part is 600 feet. So I took information from the table to label my figure. Then they tell us that the angle of elevation from the horizon is 37 degrees. So this angle here is 37 degrees. So really quickly, just because it can get confusing with the sketch of the person and the balloon, I'm just going to redraw what we have. We have a length of 600 feet here, a 90-degree angle here, and 37 degrees there. Which of the following expressions is closest to the distance d feet from Jared to the basket? So here's that d, which we see right here. So what I need to think about now is, okay, here's my angle 37. I have opposite, which is 600. I want the hypotenuse, which is d. So remember, this one over here is opposite. And then I want the hypotenuse, which is d, which remember, of course, the hypotenuse is always opposite the 90-degree angle. So when I have SOHCAHTOA, which one of SOHCAHTOA has opposite O and hypotenuse h? And it is the SO, which is sine. So once I know that I'm supposed to use sine, I can set it up. Sine of 37 degrees is going to equal opposite over hypotenuse, right? That's what the SOH stands for. I'll underline them here for you. Remember, the SO is here's the S, the O, and the H. So my opposite was 600, which of course I got from my table. That was feet, which also matches the units for D, right? They're both feet, so I don't need to worry about units. So opposite was 600 over the hypotenuse, which is D, which is what I'm solving for. So here it gets a little trickier, right? Because I have sine 37 equals 600 over D. So how am I going to get D by itself? Well, what I'm going to do is I'm going to recognize that on the right, 600 is being divided by D. So I'm going to cancel out that divided by D by multiplying by D on both sides so that I can cancel it. Then I have that D times the sine of 37 equals 600. So then to solve for D, all I have to do is divide by sine of 37 on both sides. And I get that D equals 600 divided by the sine of 37. So my correct answer is A. 600 over sine 37. And again, what made this question harder is that when we had solved with SOHCAHTOA previously, instead of it being 600 over D, which is what we ended up with, it was something like a D over 600. So after we multiplied by 600, we had our final answer. I'm going to cross that out because, of course, that's not what happened here. What happened here is that the variable we wanted was on the bottom, so we had to do two more steps, where first we multiplied by D so that we could cancel it on the right. Then after D was being multiplied by sine 37, we divided by sine 37 on both sides so we could cancel it and get D by itself. Okay, so again, triangles, we did a lot of questions. We got some great review of SOHCAHTOA, some great review of Pythagorean Theorem, a little bit of that special right triangle, and also area of a triangle. So a lot of great concepts. Triangles can appear, or triangle questions can appear in many different forms, easy, medium, and hard. 2D shapes, we're going to do two questions together. One is going to focus on rectangles, one is going to focus on squares, which are the two most frequently tested two-dimensional shapes on the SAT and the ACT. So here we go. In the figure shown below, CG, I'm going to label it right here, is congruent to AE If two things are congruent, that means that they are the same length. So what I'm going to do is I'm going to label these two blue segments both x. I'm going to use the same variable because they're the same length. Then they tell us that rectangle ABCD has a length of 6 inches. So if this length right here is 6, then I know that the distance of the length opposite it is also 6. Then they tell us that rectangle ABCD has a width of 4. So if this length here is 4, then this length here is also 4. So if we just pause for a second and think, if we look at rectangle ABCD, we have all of our lengths, or our length and our width labeled. If we look at the larger one, EFGD, notice that this total length here would be x plus 6, and this width here would be x plus 4. So when we're looking at these rectangles, when we're comparing these rectangles to each other with ABCD, we know we have a length of 6 and a width of 4. But the hard part, this initial challenge for us, was to label those two blue segments both x, so that then when we look at the bigger rectangle of EFGD, we can see that it has a length of x plus 6 and a width of x plus 4. All right, now they tell us the area of rectangle EFGD, so the area of the larger rectangle is 2 times the area of the smaller rectangle. Okay, so I'm going to pause for a second. I'm going to figure out what is the area of a rectangle. Area of a rectangle is length times width. So what's the area of rectangle ABCD? Put a little rectangle around it. It's a length of 6 times a width of 4, which is 24. Now they tell us that the area of rectangle EFGD is 2 times the area of rectangle ABCD. So I know I'm going to have 2 times the area of rectangle ABCD, which was 24. So I know that the area of rectangle EFGD is 48. Now that's not what the question's asking, right? The question is asking for the length of CG. So it's basically asking us to find what is x. So I now know that the area of rectangle EFGD is 48. But I also know that the length of that rectangle is x plus 6, and the width of that rectangle is x plus 4. So I can use that information and the fact that I know the area is 48 and work backwards to solve for x. So if I know that the area of rectangle EFGD is 48, then I know that 48 equals length times width. Well, what was length? Length was x plus 6. What was width? Width was x plus 4. So very quickly at this point in the question, because remember, our goal is to solve for x. There are 2 things you can do. The first thing you can do is go to your answer choices. Pretend x is 2, pretend x is 2.4, pretend x is 3.5, pretend x is 4. Plug in the answer choice options and then see if when you plug those values in for x, if the expression is true, right? So for example, if I plugged in 4, I would have 4 plus 6, which is 10, times 4 plus 4, which is 8. 10 times 8 is 80. That's way too big, right? I'm looking to get 48. So then I notice, well, hey, what happens if I plug in 2? 2 plus 6 is 8 times 2 plus 4, which is 6. Guess what 8 times 6 is? Aha, it's 48. So I would know that the answer is A. So at this point, you could solve either by plugging in the answer choices, or of course, kind of the more full and algebraic way to solve would be to FOIL this and then factor to solve for x, which I do want to show you because I want to make sure that you know how to solve both ways, and it's a great review of FOIL and factoring. So again, the first way I showed you is just getting it to that point, plugging in the answer choices. Now what I'm going to do is rewrite, and we're going to actually FOIL and then factor so we can solve for x. So I've just rewritten that expression with the x terms on the left and the number 48 on the right. I'm now going to FOIL. F stands for first, x times x is x squared. O stands for outer, x times positive 4 is positive 4x. I stands for inner, 6 times x is 6x. L stands for last, 6 times 4 is 24, and it equals 48. Now, for me to be able to factor and solve for x, remember that anytime you have a quadratic with x squared, it has to equal 0. So the question is, how do I simplify everything so that I have a 0 on the right? So I'm going to keep my x squared. I'm going to combine my 4x plus 6x is 10x. And then 24, I'm going to bring that 48 from the other side. 24 minus 48 is negative 24. All right, so that was FOIL and then combining like terms. Now we're going to factor. So again, great review of some really important algebra concepts that are kind of seeping their way into this geometry question on rectangles. So remember, when we factor, I need to think to myself, what multiplies to negative 24 and has a difference of positive 10? So what multiplies to 24, right? We've got 6 and 4, we've got 3 and 8, we've got 12 and 2. Of those different examples I gave you, which ones of those numbers had a difference of 10? And the answer is that 12 and 2 have a difference of 10, right? 8 and 3 have a difference of 5. 6 and 4 have a difference of 2. So we're going to use 12 and 2. Because they multiply to something negative, I'm going to know that one has to be positive and one has to be negative, because again, if they're multiplying to get a negative number, then of course one is a plus and one is a minus. So now if I know that I want a 12 and a 2, but I want their difference to be positive 10, then I know that I want to have a plus 12 and a minus 2. Now again, we can just double check our work here. Positive 12 times negative 2 is negative 24. 12 plus negative 2 is just 12 minus 2, which is positive 10. Okay, so then the last step to solve is, of course, to break this up, and we know that x plus 12 is 0, that x minus 2 is 0, which means that x equals negative 12, x equals 2. Well, guess what? Because we are solving for a distance, we cannot have a negative answer. So then after all that work, we have figured out that x equals 2. So that means that this part here is 2, and this part here is 2, and of course our answer is A. One more question on 2D shapes. We're going to now review squares, right? Our question before was about rectangles. This question tells us that the area of a square is 36 inches. Now remember, in a square that all 4 sides are the same, so I'm going to label them all S for side. They're all the same, and we have 4 right triangles. They're all 90 degrees. They tell us that the area is 36 inches. Okay, well the area of a square is S, one of those sides, squared. So if I know that the area is 36, then I know that 36 equals S squared. So I'm just going to flip how those are written. S squared equals 36. How are we going to solve for S? Because we're squaring it, we want to cancel that square by taking the square root of both sides. Taking the square root of S squared will cancel and we're left with S. Because we started with S squared, we're going to be very diligent with our practice, and when we take the square root to solve, we know that our answer is plus or minus root 36. Because we are solving for a distance, we can ignore the negative answer, and we get that S equals the positive square root of 36, which is 6. Now the question is, what is the perimeter of the square? So the equation for perimeter of a square is 4S, because you're basically taking S plus S plus S plus S, right? You're adding it up 4 times. Well, that means that it's 4 times S, which we just figured out was a length of 6. So the perimeter of this square is 24, and our answer is E. So some great review of squares and rectangles. They love testing you on these 2 shapes, so it's really, really good that you got this review. For our one question on 3-dimensional shapes, we're going to review a rectangular prism. That's the same thing as a rectangular box. It's the most frequently tested 3-dimensional shape on the SAT and the ACT. So here goes our question. To the nearest 1 foot, what is the height of a rectangular prism? Okay, so I'm going to pause for a second and just draw a rectangular prism, which remember is just the same thing as a rectangular box. So let me go ahead and sketch this out here for us. Here's its 3 dimensions coming to life. All right, I've got my box, I'm ready to label. What is the height of a rectangular prism? So I'm going to stop for a second. I'm going to put height equals question mark. That's what we're going to be solving for. With a base length of 15 feet, so if I look at the base, the length is going to be 15 feet. So I'm going to put L equals 15 feet. A base width of 1 1/3 feet. So here for my base, here is the width. So I'm going to put that W equals 1 1/3. And a volume of 100 cubic feet. So I'm going to put that volume equals 100 feet cubed. So what you have to remember is that the volume of a rectangular prism is equal to length times width times height. So let's plug in what they've given us. They told us that the volume was 100. They told us the length of the base was 15, that the width of the base was 1 1/3, and the height of the base we don't know, so it's going to stay an h. So at this point, our job is just to solve for the height, right? That missing variable. So I'm going to have 100 equals 15 times, I'm going to rewrite 1 1/3 as a single fraction. So remember what I do is 3 times 1 is 3, so I'm going to multiply here, and then plus 3 plus 1 is 4. So my numerator becomes a 4, the denominator stays a 3, times height. 15 is just the same thing as 15 over 1. So now I kind of have those fractions better lined up. I have 100 equals 15 times 4 on top is 60 over 1 times 3 on the bottom is 3 times h. I have 160 divided by 3 is 20 times h. Divide both sides by 20 to solve for h, and I get that 5 equals h. So what is the height? The height is 5, so the answer is A. Given that the volume was 100, we had L was 15, we had W was 1 1/3, which by the way is the same as 4/3, and then our job was to solve for that missing variable of height. And that concludes our review of the top geometry tips for the SAT and ACT with these example questions in geometry fundamentals. We did some great reviews on lines being 180 degrees and triangles being 180 degrees and parallel lines cut by transversals. We got to dig into more about slopes and y-intercepts when graphing and solving lines, got to solve for circumference and area of a circle, lots of good stuff from triangles on SOHCAHTOA, special right triangles, Pythagorean Theorem, and of course, area of a triangle. And then we got to wrap things up with rectangles, squares, and rectangular solids, which again are those most frequently tested 2D and 3D shapes. I'm so excited that you joined me for this lesson. I hope it was really, really helpful and that you're starting to feel more comfortable with these equations in geometry and how you're tested on them and how to apply them. Of course, you can always connect with us and be sure to also subscribe to our YouTube channel because we have lots of these helpful videos that are always available to our students.